So we're going to do an overview of a it's a high-level ecosystem or an AI ecosystem that might exist in an enterprise environment, and we're going to apply a law firm building, right, that has some sort of tool that flags contract clauses, right, that need a partner's review. All right, so that's an example I'm going to use. I can apply it to legal. I think legal is something that, at least from a business perspective, I understand at a baseline. So that's what we're going to use here. First thing that we have up top, and kind of how this entire system would work is that we would start with our data sources. Okay, we'd start with our data sources, and those would be raw. That'd be a bunch of raw data again that gets passed to an ingestion pipeline. Okay, so think things in data sources as like a law firm documents, right? So this could be the document management system that has like a bunch of contracts, matter records, billing, client intake forms, things like that, okay? So notes on how past negotiations resolved, all of that stuff, all right? At this point, this is, again, where raw material lives in general. Now we're gonna go and we're gonna pass that raw data to an ingestion pipeline. An important thing here to remember is that we're moving things through this pipeline, okay? We're not actually interpreting at this point, we're just ingesting, all right? So that's kind of where you get this idea of just pure ingestion. So this could be, hypothetically, a cron job that runs nightly and extracts every contract executed on that day with who touched it, time, version history, like all of that stuff. So again, just moving data at this point. The next part of this is the process and storing portion. So this part here, proc and store, okay? We will then be taking that raw data, right? Because it's not it can't be utilized as the model the way that it is, and it starts to get converted into features, okay? With signals that the model can actually work with, all right? So a 40-page contract in this example might become a set of values, all right? And that could be a data structure that's constructed by the actual entity that's working with this model. So that might be something like indemnity cap, that's one legal term used, whether it was used to escalate to a partner, days to signature, and things like that. Okay, so the lawyer sees a document and then the model sees this list, all right, is kind of a way to think about the process and storing part here. That step, again, the process and storing, is being fed into something called a feature store, all right? Now, the feature store is very important, okay? Because let's say if we have something like counterparty size band, right? That is a legal term. It's calculated one way when the model is trained, and in a different way. So like, let's take that for example. Counterparty size band. Let's say it's calculated one way when the model is trained, right? And then a different way when it's used in actual contracts. The model will degrade. Okay, so we don't want that happening, because that takes away from the effectiveness of the model itself. So it would be the same thing as if like we had two different associates or two different young lawyers working on a different definition of something, right? We can't compare the two things anymore because they both have different definitions of what that means. So we'd have to come back and come to a baseline. And that's why the feature store exists, to make sure that both sides of the pipeline can read from both definitions, okay? Now here, this is kind of the split. So we're gonna start kind of splitting out into two, and that's why I kind of waited to illustrate this portion, because we start splitting off here. There's two things that happen here. So number one, come up here. Sorry, I'm breaking this out way too much. This is batch retrieval. We'll get to that in a second. And then there is something called the real-time lookup. So the kind of split goes into, utilizes the same feature store, okay? We're utilizing that feature store, but with two different types of consumers, all right, at the end of this. So batch retrieval, all right, we're utilizing that for something called training, all right? So train. I might not be able to see that actually. I'll just pop in here, train. All right, so that's the training portion. So batch retrieval is offline training, okay? It's on a schedule, and that means that nobody really has to wait on it, okay? Then we're also going to run inference, which is the real-time lookup, okay? Batch retrieval doesn't need any, this is like completely offline, right? Doesn't need anyone kind of administering it. Now, real-time lookup is being used for something called inference, and that's what we would use in a real-time production environment, okay? That runs online right now while a user waits. Let's get back to batch retrieval though, before we talk about inference. So batch retrieval is just pulling a massive set, okay, of things all at one time to train the model on, all right? It's a historical set of things. So this could typically run for hours, all right? We could be here for hours and hours and hours at a time, and we wouldn't need to worry about latency or anything like that, all right? At a firm, right, that might be something that looks like grabbing a year's worth of clauses that have that are labeled with whether a partner ended up flagging it. So maybe let's say we train the model and then at that point to recognize that pattern. Let's say it runs smoothly overnight, and we now get a new kind of data point. It's something that we can utilize in the future, but also we don't have to watch that. It can just happen, right? Again, can take hours, but we can train it offline and have these kind of like batch retrievals going for different reasons. The real-time lookup is that live request, okay? So going back to the real-time lookup now, and its utilization and inference, all right? The system looks up only the features it needs for this use case, okay? So think about it being very tailored to the specific use case that is being consumed by the user action, okay? We'll get to that in a second. So at a law firm, that might look like an associate uploading a new NDA at 4. The system might retrieve the counterparty's history, the jurisdiction's risk profile, and how far the clauses deviate from the firm's standard in milliseconds, okay? Not the hours that the offline kind of batch retrieval would take, right? We're still utilizing, again, the same feature store, all right? But the access, right? The access strategy is different, all right? We're taking a few rows, right, in the inference section rather than millions of rows, all right? Eventually. So then from there, right, batch training or batch retrieval and training kind of exists on its own, but then inference kind of feeds into this, 1 second. Inference then kind of feeds into this next step, which is the prediction, right? And that is passed along to a user action. So that's us. The prediction is just the model's output, okay? So that at a law firm, it might be this indemnity clause, because again, our primary kind of example was that our law firm building that we're working with, right, in this example, it's they're building a tool that flags contract clauses needing partner review, okay? So the prediction, right, at this point, at the firm, real world example would be that this indemnity clause has an 87% likelihood of requiring partner review, okay? That's what we would get. We would get a, hey, look at this document. We think it 87% likelihood, right? Pretty okay odds, all right? but it's a probability derived from historical patterns. All right, it's not a legal judgment. All it is it's a way to validate assumptions or give you more evidence to make one action or another. Only a prediction. And then what the human does with it is just kind of the point, right? It's kind of the point of the pipeline. They can take the action. A human kind of like takes over from that point. So the associate might route that to a partner who will clear it and then kind of move on, right? And that's kind of when the user action starts dictating what the new data would be, right? Because the loop at that point is closed. So we've kind of made this round trip in utilizing a real legal kind of example, what that would look like in the real world. Couple of points that are worth noting here. We are working with features at the end of the day, okay? We're sourcing, all right? We're sourcing everything from data, but we are working with features and not actual documents because the model's not seeing an actual contract. It's very important to remember that. It sees a defined set of signals that are extracted from one, okay? Another thing to note here is that inference and training, okay, offline and online, they're about timing. All right, training has all the time in the world, and inference doesn't have any, really, because it has to happen in real time. And then the other thing is that we always work with one store, or we do in this example at least, right? There's one store, and then we have two access patterns. So training reads everything slowly, and inference reads things a little bit more like it reads things instantly, or we would like to hope that they would be instant, right? They share different definitions so that the model can kind of behave in the same way, right? In prod as it does in testing, we don't try and make those behaviors any different. So hope that kind of gives you a high-level understanding of how an AI ecosystem would work in the real world. Again, this is an ML pipeline or a machine learning pipeline from data ingestion to user-facing predictions. Okay, so hope that cleared some stuff up.